told ya, Jitum Quelly, now River Soldier. Like I told ya, yeah man, let's get started, man. So it's your boy here, man. Jitum Quelly, bacteria 25 bacteria integration, and they have a trig inverse. Integration, and then you have a trig inverse with a certain function. Integration, trig inverse. Okay, whenever they say arctan, arcsin, or arc of any trig, it means that's a trig inverse. So when you say arctan and tan inverse, means if you say this, so I'm saying it means this tan inverse of whatever function you have, and if you say arc tan, it's the same thing. So if somebody say arc tan x squared, means it's tan inverse of x squared. Same here, tan inverse of cos3x. So now let's get started, man, without wasting time. Before we get started, you know what I'm saying, don't forget to support, my merchandise. You can get it online, you know what I'm saying. You can click the link below to my shop, online shop. You can get these products, you know what I'm saying. And also, we got these products too. We got all these Dynasty and all this stuff, you know what I'm saying, you can get from my size. Now let's get to the business, you know what I'm saying. So now let's start with the first question. First and foremost, before we get to the integration of parts, now let's start with the inverse of trigonometry. Let's start with the first. So if somebody give you, let's say, differentiate, let's say tan of a function, tan of a certain function, let's say x cubed. So this is function. So what you do, take this function, then differentiate. So you say, oh, I'm going to take this function which is in here and then differentiate. So what a differentiate means, the 3 is going to come back, it's going to be 3, and then run my x, 3 minus 1 equals 2, and they say 1 plus, take this function, then it's square, means say x cube exactly, and then square. That's how you differentiate trig inverse. So this is going to give you 3x squared over 1, and this is going to be x power 6. So this is a formula here. You take your function, differentiate, and then 1 plus function square. So same with the sign. So if somebody give you, let's say, differentiate sine inverse or sine of function of, let's say, e x squared. So what you do, differentiate all these function which is in here. Means you have to differentiate whatever function which is in here. When you differentiate this, is going to give us 2x. Means you're going to take this one, differentiate. It's going to give you 2x, and then write exactly, which is going to be x squared, and then over, if you don't want to say this part, go to the differentiation of exponential function, you know what I'm saying, go to my previous video, and then you say for the sine is going to be square root. So there's a formula here, get to you 1 minus, take your function, then square. What is a function? Our function is e x squared, and then what you do, you square. So that's what you get, you know what I'm saying, and this is going to be x power 4. So is finally, it's going to give you 2x e x squared, and then you have a square root 1 minus e x power 4. You know what I'm saying? So for the cos also, you're going to do the same approach. The only difference between cos and sine, the cos you put negative over there. So I'm saying, so that's how you differentiate trig inverse. Now let's go and do the first question. So for this cos is easy. For the cos, for example, if somebody give you differentiate let's say ln of 2x. So this is cos inverse or arcCos. So what we're going to do for cos is going to be almost the same as the sine, but the only difference here you put negative, you know what I'm saying. So what I'm going to do, I'll say let's differentiate the whole of this function. Now let's differentiate. So you can even do it aside. Say, okay, let me take this function, differentiate. Okay, so I want to take my function. What is my function? My function equal to ln 2x squared. I can even take it aside and let me differentiate. Means I have to differentiate and then write the answer on top. Okay, so how do you differentiate ln? Ln, this is going to be 4x, and then 2 minus 1 equal to 1, and then you over exactly the way how it is. 2x squared. That's how you differentiate ln. Take whatever you have here, differentiate is going to be 4x1, and then over exactly. So now you can simplify. 1x and 1x go, so it's going to be 4 over 2x. Okay, by 2, 1 by 2, 2. So 2 over x. Oh, okay. So if I differentiate all of this function, it's going to give me 2 over x. All right. So now this is going to become, means when I took this function, I differentiate, give me 2 over x, but for cos it must be negative here. See, that's a formula. and then you square root. I'm saying square root, and then you say 1 minus square your function. What is the function? Ln 2x squared. Ln 2x, and then this square, and then what you have to do, you have to square also outside. You know what I'm saying? So you can leave the way how it is. Do not say this when you say ln 2x square is not equal. Let me just say this is not equal to ln of 4x power 4. No, you cannot do that. You know what I'm saying? It's not equal. Leave the way how it is. But this is equal to ln of 2x squared times ln of 2x squared. You know what I'm saying? So you hear what I'm saying? So this is equal, but it's not equal to. So you cannot only multiply. This is unacceptable. So now I believe you understand now how to differentiate trig inverse. Now let's go to the how to integrate by parts, because you cannot integrate this by parts if you don't know how to integrate this trigonometric integral. That's what I say, this is trig inverse but by parts. Now, so I don't need this anymore. You know what I'm saying? So if you come from that, so now we should be able to integrate this question. So now the question is, how I'm going to identify this is trig inverse? So like I say, when you solve trigonometry, especially trig inverse, you're going to identify. The more question you do, the more just by looking at a question, you know, oh, this is trig inverse. For example, I say from beginning, whenever you integrate by parts, if you have an integral and then something with tan inverse, that's a trig by parts. You know what I'm saying? Or it could be long, or it could be exponential. Most of the time, these are trig by parts. So whenever you see integral with trig inverse, remember, that's integration by parts. You know what I'm saying? You got integral, trig inverse, integral, trig inverse. Arctan means arcsine is inverse. Now let's start for the phase one. For the phase one solution, let's start with the solution, the phase one. So we got phase and formula. So we're going to write the formula because we have already identified this trigonometric by parts. We have already identified. So now I'm going to write my formula. You can use either the first one or the second or the same thing. Okay, let me use the second one. For example, so the integral u dv, formula uv, and the integral. Now you switch. This is u dv. Now you say v du. Okay, you know what I'm saying? So if it's trigonometric by parts, let u equal to this term. So let u equal to tan inverse of x for this case. Okay, so the next things, so u equal to this, and what happens means u equal to this, so it means dv equal to the rest. So say dv equal to dx. So what you do, you differentiate this and then you integrate this. Okay, now when you differentiate this, it's going to give it to you, and when you differentiate this, we know whenever you differentiate tan inverse of whatever function, take this one, differentiate. When you differentiate x, it's going to give you 1 over, and this is going to be 1, and then we plus 1 plus square the function. What is a function? You square the function. The function is x. When you square, it's going to be x square. Now we come here, we integrate this one. Integrate. When you integrate dv, you're going to get v, and when you integrate dx, it's going to give you x. Okay, so what we're going to do now, I'm going to take all of this and then put in the formula. Okay, cool. So now this is going to be integral. What is our u? Our u tan inverse of x. What is dv? Our dv equal to dx. Okay, u times v. What is our u? Our u equal to tan inverse of x. Okay, times v. What is our v? V equal to x. So I think it's good to multiply before. I encourage you all the time. Don't say tan inverse of x times x, because now this you might say, oh, this tan inverse of x squared, which is not true. You know what I'm saying? This tan inverse of x, or you can just put in a bracket. But most of the time, I will encourage you put the x before tan x. So I can go like that. You know what I'm saying? So I'm gonna see. What is my u? My u equal to, shows me tan inverse of x, and then times of v equal to x. But I'll multiply this x, because if you say a times b and b times a, the same thing. You know what I'm saying? So I'll just put like that. Now we go. So now we say minus integral. What is a v? Our v equal to x. Okay, now we go du. What is a du? du equal to 1 over 1 plus x square dx. You know what I'm saying? So now we go. So now this is going to give us, okay, x times 1 equal to x over 1 plus x squared. So this is going to be x tan inverse of x, and then we minus integral. It's going to be x 1 plus x squared dx. Okay, so now you see it's not done yet. So what I'm going to do, I'm going to take these separate and then integrate separately. So now after we integrate this stuff here, it take us here. So we still got a problem here, man. You know what I'm saying? The problem is in here. So I'm going to take these separately and deal with it separately. You know what I'm saying? So now since you have this and you know how this works, I'll just erase the part, you know what I'm saying? Because you know the business. So I'm going to erase this so we know now. So I don't think we need it. So I'll just erase it. So let's make a space here. Okay, so now, so the next thing what you do here, you know, we took this over there, so this is easy. So what I'm going to do right now, you know what I'm saying, I'll do trigonometric substitution. You know how I'm going to do substitution? Because I know if I'm going to let this and the differentiate, it's going to give me the one on top. So I'm going to let, let's say let t. So I'm not going to use u and v because, so this is not integration by parts. This is trigonometric by substitution. It's very easy, this one, because now look, if I differentiate this, it's going to give me the one on top. How? Let's check this one out. You know what I'm saying? So now I'm going to let, let's say t equal to 1 plus x squared. So now if I'm going to differentiate this, it's going to give me dt. If I differentiate 1, it's going to give me 0. And then if I differentiate 2x, it's going to give me 2x dx. Means if I differentiate x squared, because I'm going to take 2 back, x squared. So I want to get this, look, this is what I want. X dx. So this is what I want. So what is x dx? X dx means dt over 2 because I have to divide it by 2 divided by 2. So I'll say x dx dt over 2 equal to x dx. Okay, so what I'm going to do, I'm going to replace x dx with dt over 2. So that's going to become integral. Instead of say x dx is going to be dt over 2, and then this is going to be 1 over this stuff here equal to t. So I'm not going to write this, so say over t because it's at the denominator or t. So now this equal to, I'll take a half back, means 1 over 1 and 2 is going to come behind 1 over 2, and they'll say integral. So this is going to be 1 over t dt. So now when you integrate 1 over t, you're going to get ln of whatever you have here. So this, let me say 1 over 2 ln of, whenever you have a 1 over t, ln over t. You know what I'm saying? Put your absolute. Oh, wow. So now I have already integrated. We go half ln t. But we know the value of t. What is t? T is 1 plus x squared. So this equal to a half ln. So I'm not going to write t. I'm going to say 1 plus x squared. So 1 plus x squared. So I'm done already. So what I'm going to do, I want to replace this one here with this stuff here. You know what I'm saying? Because if I differentiate all of these, finally it give me a half ln da 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 da. So now then this, let's call this question number 1. So question 1, see, question 1 is going to become, question 1 becomes, so question 1 is integral. That's what we're looking for, you know what I'm saying? Well, that's our given equation. Tan inverse of x dx is going to become x tan inverse x tan inverse of x minus. So now instead of say this, I'm going to write that. I have ln 1 plus x squared absolute. But we know what a plus constant. You know why we know what a plus constant? When we're given a question, they give us 0 to 1. You know what I'm saying? So we have to put our limit 0 to 1. And they have to say everything must be 0 to 1. You know what I'm saying? 0 to 1 finally. So what I'm going to do, I'm going to take upper limit, substituting the value of x everywhere, and then minus, substitute the value of, okay. So upper limit minus lower limit. So these values are going to become, so now take the upper limit, substituting all these value of x. So here's going to be 0. No, apologies. Sorry. Upper limit is 1. So I'm going to take this 1, substitute in either way in the equation. I'm going to have substitute in the value of x. So I'll say, oh, so this is going to become, instead of x, plug in upper limit, which is going to be 1 tan inverse of 1 minus a half ln 1 plus 1 squared is 1. So it's 1 plus 1 squared equal to 1. So 1 plus 1 equal to 2. Ln of 2. Oh, so I've already substituted the upper limit. Now minus, we take the lower limit also. We do the same approach. You know what I'm saying? The same way we do for the lower limit. So now I'm going to take 0. So 0 is going to come here. 0 tan inverse of 0 minus a half tan, a half ln 1 plus 0 squared is 0, so 1 plus 0 equal to 1. Okay, the bracket. So now we're going to have to simplify this. Tan inverse of 1 equal to 45. Or pi over 4. Pi over 4, okay, minus a half ln of 2 minus 0 times anything is 0. So this part here is going to be 0 minus ln of 1 equal to 0. So here is going to be a half. You know what I'm saying? So negative and negative is positive. So this is going to be positive a half. You know what I'm saying? So 0 minus a half is negative a half. Negative times negative a half equal to positive a half. So I can replace these, you know what I'm saying, with a positive a half. Say plus a half. So the next step, take your calculator, plug that one in. This is what I'm saying, and then you're gonna get your final answer. Let me check in the calculator quick, and let's get a final answer, you know what I mean? So the final answer for this is gonna be pi over 4 minus ln over 2 over 2. Pi over 4 minus ln over 2 over 2. So it's gonna be pi over 2, so it's gonna be pi over 4 minus ln of 2 over 2. You know what I'm saying? So now look here, man. Yeah, ln of 2 over 2. Yeah, ln of 2 over 2. So if this is the first time on my channel, make sure you click the like button, subscribe, and share to a lot of people. You know what I'm saying? And also don't forget to support my music, man. You know, just click the link below. You can see my music. And if it's the first time, like I say, subscribe. If you don't understand anything, leave the comments. You know, give it credit. If the credit, you think the credit due. You know what I'm saying? If you think I deserve the credits, and then give me credit. Give my credits. If you think I don't deserve the credits, no problem, man. But I appreciate your time. I believe you learn from me, and you learn from my mistakes. You learn from my methodology. Peace and love. Do not forget to subscribe, you know, to my other channel where the music at. Click the link below. Peace and love, man. Tell me what you think. Support your boy, man. You know. Thanks a lot, man. Peace and love. Bye bye. Thank you.